Hello guys, in this very lesson, we're going to be discussing a new topic on mathematics known as modular arithmetic. And when we talk about modular arithmetic, what are we talking about? We're talking about a branch of mathematics that deals with how various integers wrap around when they get to a given peak number. Now, when we talk about modular arithmetic, a couple of great mathematicians of old and of recent times, mathematicians such as Euler, such as Euclid, and a couple of them, did a couple of works on number theory, which is virtually the same as modular arithmetic. But in recent time, a major scientist, a German scientist known as Gauss. The full name is Carl Friedrich Gauss. In 1801, did a major work on modular arithmetic, and he's been called the father of modular arithmetic. So, talking about modular arithmetic, it's a branch of mathematics that talks about how numbers wrap around when they get to a given peak number. Now, that's what I mean. Look at what I mean here. For example, when we talk about the 12 hour clock, for example, because modular arithmetic is also known as clock. We call it clock math. That's how we call it. You can call it clock mathematics. So we talk about, let's say, a 12-hour clock, for example. Now, for a 12-hour clock, if the time is 10 o'clock, for example, let's say the time is 10 o'clock. Let's say it's 10 in the evening, 10 p.m. or 10 o'clock, whatever it is. Now, if the time is 10 o'clock, if 5 hours is being added to 10 o'clock, what's it going to be then? Just 10 in the evening, 10 p.m. in the evening, 10 o'clock. Now, if you add 5 hours to 10 o'clock, what time is it going to be? Don't forget that this is a 12-hour clock. We're not talking about 24-hour clock. So if the time is 12 o'clock, for example, it's 10 p.m. Let's say we have a clock here. There's 12, there's 6, there's 9, there's 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, this is 12 here. 12 is the peak. So this peak number is what we call the modulus. We call this peak number the modulus. So when we talk about modular arithmetic, that's what we are talking about. Numbers don't exceed certain peak numbers. The peak number or the highest number here is 12. So whatever gets to 12, you're not going to get 13. Since you're talking about 12-hour clock. Once you get to 12, it goes back to 1, 2, 3, 4. Then we keep repeating that same circle. It gets to 12, goes back to 1. We don't have 13. The highest is 12. So this peak number, this peak figure, the peak figure is what we call modulus. So nothing exceeds this peak figure. So for example, if the time is 10 p.m. or 10 in the evening, and 5 hours later, what time is it going to be 5 hours later? So if it's 10 o'clock, 5 hours later, you know what's going to be? That will be 11, 12, that's 1, 2, 3, 4, 5. 5 hours later would be 3 a.m. That is 3 o'clock in the morning. So this is what the modular arithmetic is all about. So it's a clock mathematics. So today we are not going to be looking at the complex part of it. We are going to be looking at just simple introduction into modular arithmetic. We're going to be looking at what it looks like. It's something we are all very used to. Since we do division of numbers on a daily basis, we are very used to modular arithmetic. So it's known as clock mathematics. For example, 12 o'clock, you could also have a 9 o'clock, clock. This 12-hour clock, You could have a 9-hour clock, you could have a 24-hour clock. For example, if this is let's say if this is a 13-hour clock, 13 hour. Now, if this is 13-hour clock and this is 10 p.m., then 5 hours later is going to be 2 a.m. So more or less like number base also. Number base looks very much, quite like this, but not exact. So now there are various things we use the modular arithmetic for. We use it during cryptography. We use it even in our calendar. We have 7 days in a week, so we have Sunday, Monday down to Saturday. That's 7 days. We don't have the 8th day. So we go back to the day 1 again. So 1 to 7, there's no 8th day. We come down to 1 to 7, 1 to 7, that's 7 days a week. So unlike cryptography is used to encode our WhatsApp communications, our WhatsApp messages. If not for the knowledge of modular arithmetic, there's no way these messages will be encoded or be kept, secret. So we're going to be looking at simple introductions into them. Simple introductions. So we're going to be looking at this. For example, these are just simple examples on the modular arithmetic. So first of all, we're going to be looking at two things. We're going to be looking at both positive digits and negative digits. So for example, if I say 21 should be written in 21 should be written in modulus. Let's say 21 should be written in modulus 9. This plus 21. If we want 21 to be in modulus 9, that means 9 is a standard. Nothing exceeds 9, just like the 12-hour clock. That means once we get to 9, we are not going to have 10. So it has to be 1 to 3 down again to 9, just like that cycle, just like multiples of 9. So 21 in modulus 9, this plus 21 in modulus 9, and minus 21 in modulus 9 also. So let's see what this looks like. This positive 21 in modulus 9, negative 21 in modulus 9. We're talking about 9. 9 is a major modulus. 9 is the peak figure, the peak point. Whatever gets to 9 repeats that same cycle. So how do we write 9 in modulus 9? What's it going to be? It's going to be equivalent to what? Now don't forget, this is 21, I beg your pardon, divided by 9. So we have multiples of 9, 1 to 3 to 9. So we have the first row of 9, this row 1. We have the second row of 9, that makes it 18. This row 2. And then this 9 and 9, 18. The third one is not up to 9, so you just have remainder 3, which is an incomplete third row. So this very third row is not complete. So this third row incomplete. So what do we have? The result is going to be 3 modulo 9. Just like this. If the time is 10 p.m., in the next 5 hours on the 12-hour clock, 10 p.m. is 3 a.m. on the 12-hour clock. That's 10. In the next 5 hours, that is 1, 2, 3, 4, 5 is 3 o'clock. So how do we get to know that? We got to know that this is 3 o'clock because of the fact that we're dealing with a 12-hour clock. So from 10, next 5 hours on the 12-hour clock is 3 o'clock. So the same thing here. The same thing. So for 21 to be written in modulus 9, this is positive 21 to be written in modulus 9. So we have the first round 9, second round 9, which is 18 altogether. The third one is not up to 9, which is 3. So that is the answer, which is 3 modulus 9. That is the result. So there's another way you could do this, just like our normal division of numbers. You can create a 9 times table. This 9 times 0. This 9 times 0. The 9 times table. 9 times 0, which is 0. 9 times 1, which is 9. 9 times 2, which is 18. 9 times 3 is 27. What we are looking for is not up to 27. What we are looking for is 21. So our answer is 18. So what's the result? How many 9 do we have in 21? It is 2 remainder 3. 2 remainder 3. So what's that? 3 modulo 9. That's what it is. 3 modulo 9. So that's that for the positive result. So 3 modulo 9, as simple as that. So let's see what the negative stuff is. Minus 21 in modulus 9. How do we solve minus 21 in modulus 9? So it's still the same thing, but this time around, unlike when we have positive 9, look at this, a positive result. These ones are positive. That is plus 9 times 0, 0, plus 9 times 1, plus 9, plus 9 times 2, plus 18, and so on and so forth. We keep looking for 21. Either we get 21 or we get a figure extremely close to 21. So now the same thing we're going to do to this. This minus 21 divided by 9. So we're going to create the same table. We create a 9 times table. But this time around, we're going to be going down the other way. We're not going to keep going up. Look at this, 9 times 0, 0, 9 times 1, 9. Just keep going. But this, you're going to be descending. You're going to keep going down like this. So that will be 9 times 0, which is 0. Now after 0 is minus 1. 9 times minus 1 is minus 9. Don't forget, we are looking for minus 21. We are looking for a figure that is, we are looking for either minus 21 or something extremely close to minus 21. So 9 times minus 1 is minus 9. 9 times minus 2 is minus 18. And don't forget, minus 9 is bigger than minus 21. This one's, we are talking about negative digits here. Minus 18 is bigger than minus 21. So we are looking for something close enough to minus 21 or minus 21 itself. So 9 times minus 3 is minus 27. Minus 27 is smaller than minus 21. Minus 18 is bigger. So you're looking for minus 21 or something very close to it. So minus 27 is the nearest to minus 21. So what I'm going to pick, so 9 minus 21 is simply minus 3. That's the result. Remainder, minus 3 remainder what? That's minus 3 remainder. So this is what you're looking for, minus 21 minus 27. Minus 21 minus 27. That's minus 21 plus 27. That will give us 6. So minus 3 remainder 6. So what's out? So this remainder is simply the modulo we are talking about. So the answer is 6 modulo 9. That's the result, as simple as ABC. So there's something I want to point out here. There's something I want you to observe. Now, whatever we are dealing with, now don't forget plus 21 and minus 21. These are congruent. You can call them congruent. Yeah, they're not really congruent actually, but they share something. There's something I want to point out. They share something, quite alike. Now, for when you observe the positive 21, you get 3 modulo 9. Now, for the negative 21, now if you are given something like this, the negative stuff to solve, you can solve the positive stuff. And when you get your result, now look at this, the 3 modulo 9. You use your modulo 9, you take away this very figure, that's the base remainder. You take it away from this, which is 9 minus 3, which gives us 6. So 6 modulo 9. So it's vice versa. So if I have this plus 21 written in modulo 9, now minus 21 written in modulo 9 is the same as using the modulus, that's the major divisor, that's the peak figure. We take away the remainder from the peak figure, you get our answer immediately. So 3 modulo 9 for plus 21 minus 21 is 6 modulo 9. So it's as simple as ABC. So I'll give you a couple of questions to try yourself at home. This for for take home, their homeworks. I can call it homeworks. So here's it minus 50. That's plus 51. I mean 51 and minus 51 to be written in modulus. To be written in modulus 12. That's the first question. The second question, 35 and minus 35 to be written in modulus 17. So those two major questions are very good. They will get us tested to see how much we've gotten. I forget, this is just an introduction. Now, in the next set of lessons, we're going to be looking at the more complex part of modular arithmetic. So you will solve 51 in modulus 12, and you also solve minus 51 in modulus 12. I've shown you how to do it already. So when you get your results, the one in positive or even the one in negative, just take away the remainder from the modulus, you will get the result for the other one. So that's very point we're drawing the curtain on this very lesson. If you found this lesson helpful and resourceful, please follow me at Revelation Hub on Facebook and also subscribe to this very channel at EduMosaic on YouTube. So see you in the next lesson. Thanks.